Captain 315, TikTok, Scotty Ender 315. We're back again in true squirrel fashion. You remember, powered by Super Squirrel. I'm jumping around here a little bit and jumping ahead. You have seen the basic port job, and I promised you the next one would be the improvements on that. But first, I'm going to show you some little fun things until I can get back to the porting. Today, we're going to play with paint and Play-Doh. Remember Play-Doh when you were a kid? Yeah, you rolled it up, you stuck it up your nose, you put it in your sister's hair, and got your ass kicked. And then you went out in the garage and you picked up your dad's paint cans and painted something like maybe his car or something, and you got your ass kicked again. Well, we're kind of adults now, so we're going to play with this. But before we go any further on that, thank you all so much for tuning in and subscribing and liking. This is starting to gain ground. You may have noticed that I kind of changed the title and descriptions a little bit and also included Mud Mower in there because the Mud Mower guys have really been showing some attention here, and it seems to be heading in that general direction. Remember, this can apply to anything. I want to thank, if you know the Mud Mower community, you know Studebaker, and you know Red 02. Thank you both for pushing me in the right direction to change the title and description and try to get more people to notice this so that it can be found. Thanks, fellas. I appreciate you. You guys are the best. All right. We're going to go back to paint and Play-Doh. What can we do with this besides shove it up our nose, right, and get our ass kicked? Wet flow testing. This is uncharted territory for me. Have always done dry flow testing, but you know, it's nice to know where your fuel is going as well as your air. Air is lighter than fuel, obviously. Air wants to go straight. Remember me talking about that in the past. If there's one thing you can take to the bank, and I want you to remember out of all this crap and rambling, air wants to go straight. Fuel, well, we're going to consider that fuel. That really wants to go straight, okay? So, as an experiment, I actually pulled the manifold off of the B1 Bomber. There's the spacer for the Kohler carb. Ooh, got a nice little port job going on in there. Oh, there's a rag in that end, and I'll show you why. We talked about the intake itself. Now, if you look right here, remember, again, air wants to go straight. If you look at this piece of the casting, you can actually see what that port's like, okay? If you've had a flathead engine apart before, you know what the port's doing, okay? It's going in, it's got to make a 90 and go straight up, and then it smacks the valve and goes down the cylinder, right? On the intake stroke, we're talking intake here. Okay, what I noticed when I shot a little bit of paint in here, now I was doing it at low lift, like 100 thousandths, and I was doing it at high lift, close to 400 thousandths. What I noticed was, number one, at low lift and at high lift, spray the paint in there, air wants to go straight, right? What's it doing? Boom, hits the back of that port and then climbs it. So I had paint. Let's pull this valve out of here. It's since been repainted and cleaned and repainted, and I'm using black for a tracer, but the back of the port had paint on it. Well, when it hits that, the air and paint, fuel, the mixture hits that, turns and comes up. It has to turn, right? What's right in the way? There's your valve. Smacks that valve and goes forward. At high lift, it is going to tend to want to go straight. The valve's not as much of an obstruction, and it hits the head. That's exactly what I found with fuel. I found at low lift, this is a big flathead Ford V8 thing, and the cart guys, the Briggs guys do it and stuff too, is relieving that. That's an area of controversy, whether it works or not. In this case, that absolutely works. At low lift, I had paint all over this. So it shows that that was, I mean, if there's paint on it, the air is hitting it and you need to get it out of the way. Could you do this with paint and then just keep chasing the paint and grinding away? Sure, you'd probably pick up flow. We're not going to get into that. Some of these things, a lot of these things, there's only so much material you can move, okay? So I noticed paint there at low lift. At high lift, that was spotless. It was all up here on the cylinder head. Don't worry about this paint here. We're going to get into that next. It was all up here. It seemed to favor this side, and I had red paint running all up this way and a little bit over here and here. Okay? So in my squirrel brain, I thought, well, what's going to happen? Look at this. We're going to introduce another turn into it. Now, depending on what engine you're doing, obviously the vertical shaft Briggs Oppose, which most of you guys are running vertical shaft engines, you've got a pretty long runner here. I would say if you've got any kind of an intake manifold, the Kohlers, the old K series and stuff, you pretty much got no intake. You got a carburetor there. It's a straight shot. If you've got a straight or a relatively curved shot, as in slight, you could probably flow it right off this port. All right. The Play-Doh. Play-Doh is for putting, remember we talked about putting a little radius on here. Take the Play-Doh, roll it out like a turd, and just kind of make it nice and neat around there. I actually saw a 1 full number decrease in restriction by putting a piece of Play-Doh on that port at high lift. Again, just repeat what you're doing. Put the Play-Doh on, then you have to put the Play-Doh on every time, and probably ought to try to make it relatively the same shape. If you're not going to put it on there, don't worry about it. Okay, intake manifold goes on. Now we're making a turn this way into the port, turning up, smacking the valve and going into the cylinder, right? Air wants to go straight. Fuel really wants to go straight. Put it on here, low lift, high lift, whatever. See that? What was the air doing? Going straight. Fuel's going straight. Even more so. Bam, it's hitting the back of that. Now, hitting the back of that intake manifold, where's that? That's no longer at the bottom of this port or in the center. That's at the top. As soon as that happened, this is the shape we got. And we'll get into this, talking about relieving the chamber, unshrouding around the valve. Low lift and high lift. Look at that paint. That's all because of putting this intake on there. This showed gains in airflow, but showed absolutely no red paint until I put the manifold on. So, in thinking, well, if you've got any kind of a flathead engine that's got an intake with an immediate curve like this coming in, well, that's firing all fuel up here and the mixture and the air, of course, as we're saying. That's telling me that this unshrouding is super important. There was zero paint on this, low lift or high lift, because it's working off the roof and hitting the back. Once the valve is open all the way, it's open up high. Now it's coming off the roof of this port, short turn, and right over. Not even touching this. It's all on the head. Enter Play-Doh. Start over. Bolt the intake manifold on. Take some Play-Doh. Get rid of that relief that was cut in there, right? This is, if you're doing the experiments, this is where I'm telling you, you might not want to do this. You know, go get an old junk block or something. Obviously, this is a junk block because I've been playing with the Play-Doh in it and made cuts and everything else and saw improvements and saw losses. So, put this back on there and float it. Still gained airflow. There was a loss with the Play-Doh there. Mainly at low lift, very little difference at high lift, but there was a measurable gain. So, relieving that, even though wet flowing it showed that there's no fuel contacting it there, absolutely works. Then, we took a stock cylinder head without the unshrouding. Ran the test again. Major difference. Low lift, medium lift, high lift, all the way up, because this intake with a sharp 90 in it is throwing the fuel onto the short turn, smacking the valve, coming around the back side of it. So this has been repeated time and time again. This works, this works, this works, okay? Not so much at high lift, at low lift. That's where you're gonna get your gains. It's where you're gonna get your torque. Get that valve open, get that cylinder filling up fast. This unshrouding absolutely works. Now, that's with an intake with a 90 on it. It also works with a straight. If I was a betting man, I would say if you were building your own manifold and had some kind of a straight shot like this, my guess would be that you probably don't have to be as critical about the unshrouding and more critical here. On the flip side, if you're doing an intake that's got an immediate curve, I don't mean way out here, I mean if you've got a curve coming right up to that port like these horizontal manifolds are, then my thought is, and Flowbench proved it, that you're probably going to be more concerned with this than with this relief. However, both gained airflow. Another trick with a Play-Doh. When you have this all set up, let's turn it around so you can see the port, okay? You're going for peak flow numbers. You got that valve opened all the way up, okay? You got the cylinder head on, valves open all the way up, and you got that shop vac running. You got your manometer hooked up here. Play a little bit. You're out there, you're bored, you're drinking a beer. Take a screwdriver blade, a nail. You could use something as small as a tiny drill bit. And while that's running, take this and move it around the port. And angle it this way. Try to guide the air in different places and watch your manometer while you're doing this. You will see that you might actually take this and put a restriction in there like that and have the airflow pick up. Sometimes to a great degree. The second generation GM LT1 factory heads were famous for that. They don't flow worth a crap. You can't get anything out of them. You put a little restriction right in the center, right here on the short turn, the numbers go through the roof. I have proven that. It's out there. What else can we cover? Okay, we covered that. Your screwdriver blades, trying to mess with that. You can also go in there with your Play-Doh. It's like, ooh, you know, this makes a pretty sharp turn in there. Let me roll up some Play-Doh like a turd, stuff it down in there, and I'm going to kind of redirect that air to more of a smooth turn. Fire up the shop vac. See what happens. Play. You're out here, you're bored, you're drinking a beer. You know, at one time we talked about taking one of the ports in this junk block and just hogging the snot out of it, basically taking everything out of it, and then build it back with Play-Doh and see what works. That didn't happen, and one of the main reasons is, number one, most of us aren't going to get into these things quite that far. Number two, you can't, there's certain areas in these ports, especially on the flatheads, where you can't add material. If you want to get into TIG welding one of these things up and redesigning your own ports, go for it. You're above and beyond what I'm going to be covering here. This is for your regular guys trying to have some fun and pick up some power. The Play-Doh is a nice experiment. Even though that simulates filling your port, it will still tell you, well, am I gaining anything? Am I losing anything? I actually filled the back of this port expecting to see massive gains, although right from the factory, there's nothing back there. So I'm not going to fill it. It's an experiment. Gained 0. Another thing, take a little Play-Doh, stuff it on one side of the bottom of the port. See what would happen if you're inducing a swirl. I did that. I saw actually a slight decrease in flow no matter where I put it. Did the same thing with the nail. So try it. It's really interesting if you sit here and run this and start moving this around. Really, you're going to see a flow reduction. As much as the head of that nail, like this, you will see a flow reduction. That's telling you that your port is active all the way around. What else can we cover? Oh, looks pretty good. So it's been a couple hours of just playing out here and rolling numbers. Let's drop off here. Remember, air wants to go straight. Air wants to go straight. Fuel really wants to go straight. There's your I can't speak today. There's your proof, right? That air is hauling ass down this manifold and it wants to go straight. Bam, it's hitting right there. Yes, the air is doing it too to some degree, but the air will follow the entire thing because it's trying to fill you got a port this big and it's trying to fill a cylinder that big. So the air will follow short turns. The more gradual, the better. But your fuel is trying to go straight. If you get into playing with the paint like that, if you start getting really into this stuff and you're experimenting like crazy, I'm not real familiar with it. It's uncharted territory. My opinion would be that you would want to get in there, and if you want to do some grinding wherever you see paint marks, you're going to want to make sure that that paint is evenly distributed once it gets in the cylinder. You don't want to see any defined half-inch wide path with just paint running off like the cylinder head was doing with no intake manifold on. I actually thought we had trouble there, and it ended up being all right once the intake's on. Another thing you can do, let's go back to this real quick, back to the port. Fire up your flow bench. Get a piece of PVC. Yes, actually port it. Get rid of that sharp short turn in there. Yes, I actually hogged out a piece of PVC. Get something relatively the same size as the intake manifold, maybe a little bit bigger, certainly not much smaller. Go ahead and fire up your flow bench at full lift. Take that and roll it around. You'll be really surprised what you find. I found that this direction right here, anywhere between here and here, is going to actually give you better flow than this way, like the factory manifold. But this is the second best to here and here. My thought is, if you're doing it this way, your air is coming down and it's making a straight 180 going up to the valve. If you're doing it this way, you've got opposing 90s. Wants to go straight, right? Right. There's a little intake manifold designed for you. We're not getting into this. These things flow massive amounts of air compared to a vertical intake manifold. No matter what you have for an intake, unless you're going to run a straight carburetor right here with a velocity stack or a straight shot, no matter what you do, when you put an intake manifold on, you are going to have some kind of restriction. Minimize it. Make your carburetor your main restriction, and you're going to make all the power. All right, folks, I really promise you this time, next episode, we're going to start getting into the real porting. Stay tuned.